All right, so we're going to do the bomber problem linearization formative. Please try this first. This is just my solution, but honestly, I'm doing this blind, so you can see how I think through it. Physics students are running an experiment with this bomber problem where you're given an initial velocity v1 horizontally, and they actually can measure the final speed at v2. So let's go ahead and start. Hopefully they give that. Okay, they do. Multiple choice. The students derive an equation for the square of the final speed v2 in terms of v1h, and we got to find that expression. So remember, velocity is a vector, and there's components to it. So if I draw v2, there's going to be the v2y component and the v2. I should not draw a 2 there. There's the v2x component. So v2 squared, right? This is what we're deriving for. It's just Pythagorean theorem. v2y squared plus v2x squared. And then, so v2y squared. v2y squared. I don't know why I thought that. This is, we want to use kinematics for this. We know that we know that v initial y is 0. We know that the change in y is just negative h. And so, negative h. And then we know the acceleration is negative g. We know that we're trying to find vy final. So the equation we can use is vy squared is going to equal v initial y squared plus 2 a change in y, which is just negative g, negative h. This is the third equation on your physics C equation sheet, and this becomes 0, and you get pretty quickly vy squared is just 2gh, right? So this is our final equation, right? And v2x, right? This v2x is just equal to v1. It's constant, right? The x component, the velocity. So we get v1 squared. So 2gh, awesome. They're gonna vary the height, and we want to measure v2 as a result. So, this is cool. All right, so we're gonna vary the height and measure v2. So hopefully you can kind of see we have a v2 squared, and then the 2. V2 squared is proportional to h. That's the thing you gotta look for, right? Is what's the proportionality? v2 squared is proportional to h. So I'm gonna graph v2 squared, and we're gonna graph it to h. Right? So we're going to create a linearized graph. So when we do this, what's the slope going to be? The slope's going to be 2g. And I just realized we're actually going to have to probably plot the data. Okay. So the slope is probably going to be 2g, or it is going to be 2g. Oh, I don't know why I'm doing that. It's going to be twice the acceleration due to gravity. The y-intercept is going to be v1 squared. So v1, where is it? And the square of the initial speed. Okay, that should be good. We're gonna have to actually graph this. That's really annoying, in all honesty. So I guess we can. How do I want to do this? Maybe I should just tell you guys how to do it, and then you guys can go do it. Okay, let's do this, right? I'm going to show you guys how to do it, and then you guys can do this on your own, because you would have to use a program for this. But basically, we want to do v2 squared versus h. So v2 squared versus h. So we just square all of this data, right? Instead of 7, we're going to do 49. Instead of 9.2, it's going to be 81 something, or maybe 82. I'm not sure. It should be 81, right? In fact, you could actually, figure it out if you do 0.2, do binomial. So it would be maybe 82. 11, 121, that sort of thing. So we would just square all the data, and to find the initial speed, we would just, when we interpolate things, I guess, we would, or is that the word? Or when you graph your trend line, your y-intercept, right? When I plot all the data, I get this sort of trend line. So my y-intercept is v1 squared, and the slope is going to be 2g, and then I can solve for g. So yeah, thank you. Hopefully this made sense.